To you, viewer. My name is Collins Tendasaguru, and today I am going to be giving you a presentation on a scientific topic, on an engineering topic, but I'm going to make this as non-technical as possible. And the purpose of this particular video is to at least just give you a brief overview of what I've been working on and what I've been trying to do. I'm enrolled at the University of the Witwatersrand. I'm doing my master's within the School of Chemical and Metallurgical Engineering. And my research project, or what I'm trying to achieve, is to actually develop a particular process to recover or recycle platinum group metals, which are precious metals. We're talking about platinum, palladium, and rhodium, from what we call used autocatalytic converters. Now, what you might not have known is your car might actually have some some precious metals installed on it, but I mean, obviously they're going to be very little, so you can't actually take them out and like try to sell them, and it's actually illegal, I should think. But essentially, modern cars are equipped with what we call an autocatalytic converter. Now, this particular device has got platinum, palladium, and rhodium, which are doped into its structure, and then it is attached to the exhaust line of any fossil fuel burning engine. So we're talking about the exhaust line of your diesel car, your diesel truck. We're talking about your petrol car. The purpose of the platinum, palladium, and rhodium, and essentially the whole autocatalytic converter, is to just convert toxic gases produced from the burning of the fossil fuel into less toxic gases. So essentially, we're talking about the conversion of, say, unburnt hydrocarbons from the fossil fuel engine into less toxic gases like just water and carbon dioxide. We're talking about the conversion of your nitrogen oxides, which are very dangerous. They cause acidic rain. They might have implications on people with asthma, say respiratory ailments. They result in the formation of photochemical smoke into less toxic gases like nitrogen and oxygen, which are quite abundant in the atmosphere. So this is what the autocatalytic converter has been designed to do, and what its purpose is on any car. Now, because of the particular environmental significance of this particular piece of device, and because of the environmental significance of the platinum group metals, their demand has recently been growing. And that has consequently resulted in the growth within the South African industry, within the South African PGM industry, because South Africa is the major supplier of these particular PGMs, because it is quite endowed, and there's quite a lot of these particular PGM reserves within that country. So as a result, South Africa has quite grown phenomenally. The South African autocatalytic converter manufacturing industry has quite grown phenomenally, supported by PGM supply from mining predominantly. However, the mining industry has been facing quite a number of challenges, and as a result, globally, recycling of PGMs has actually quite also been increasing. Challenges within the mining industry are numerous. We're talking about, the need for sustainable mining, which increases costs. We're talking about labor unrest in South Africa. For example, the Marikana strikes of a few years back. We're talking about energy challenges. South Africa was also going through quite a number of energy challenges some time back. We're also talking about declining ore grades. We're talking about depressed commodity prices. Now, all of these challenges on the South African mining industry have actually been unbearable, and they've made PGM mining quite unsustainable. So globally, people have looked into recycling PGMs from end-of-life devices, for example, autocatalytic converters. So around 2000 there, recycling PGMs was only at around 10%, providing 10% of the supply of PGMs globally. But now, as far as let's say 2016, just last year, around 30% of PGMs was now coming from recycling, illustrating the growth in the recycling industry of PGMs. But the problem with the particular recycling processes that are being used is the high temperature processes, pyrometallurgy. So what we have decided to do is to design a process that is hydrometallurgy based. What we're simply saying is we want to get those particular PGMs out of that particular structure. So after the car is no longer in use, we'll dismantle the PGM containing structure, the autocatalytic converter, crush it, and after that we'll leach the PGMs out of that particular solution using an acidic and an oxidizing environment. You don't need to actually really to get to know that, but the thing is we're just trying to leach the PGMs into a solution, remove the platinum, palladium, and rhodium from the structure into a solution. The solution will be an acidic solution, and it will also be a highly oxidizing solution. These are the conditions that are required. Now, after that, essentially, we're going to recover the PGMs out of the solution using what we call solvent extraction, using tertiary amine. Now, essentially, we're just trying to extract and purify the solution so that we have our PGMs. We'll precipitate them out, and then we'll go and ignite them so that we actually have a PGM sponge or a PGM, a relatively pure PGM in the solid form, or a PGM salt or a PGM precipitate. The reason for this particular process that we're trying to develop is a hydrometallurgy based process is going to consume less energy. Number one, because pyrometallurgy needs to actually melt everything. So we're talking about temperatures in excess of 1500 degrees. A hydrometallurgy, we're talking a temperature of at most 100 degrees Celsius. Beyond that, we are also going to have advantages of core metal or core values extraction. The autocatalytic converter has got quite a lot of other metals that are present in it that cannot necessarily be extracted if you use a pyrometallurgy based route, which is where we're saying a hydrometallurgy based route can come in, and then we can actually try to dissolve everything, and whatever it is that we dissolve out of that particular structure, we can find ways that are economical and sustainable to actually recover the metals as well out of solution. Apart from that particular, those two particular advantages, we're also saying hydrometallurgy. We're actually saying growing the recycling industry within South Africa is not only going to create jobs, but it is also going to give South Africa a major boost. It is also going to give South Africa a major buffer, in times of really bad mining seasons. As you know, mining goes through seasons, commodity prices go through seasons. When times are really rough and when times are really bad, PGM recycling can actually come in to try and augment that particular period in time when things are not really going on well for the South African economy. And we're saying all of these can be attained, they can be achieved if this particular process here is quite developed and it is taken to a commercial scale. So that is what we're simply trying to do. Essentially, we're just trying to recover and recycle PGMs from these autocatalytic converters when they have reached their end of life. And yeah, I guess that concludes everything that I'm trying to do. If you have any questions, please do not be afraid to just drop in a comment, and I'll try to answer you as to the best of my ability as I can. Thank you very much.